My research falls in two areas. One is economics, and the other is liquids, such as water. You might think that these two systems have very little to do with each other, but in fact they do. And the reason is that both are dependent entirely upon very abrupt transitions. Certainly this is true in economics. What matters in economics are the abrupt changes. That's what all the attention is focused on. And also in liquids, the change of phase of one liquid form, such as water, to another liquid form, such as steam, when we boil water, is fundamental importance, not only scientifically, but even mechanically. Engines are called steam engines, are the basis of almost all of transportation for many, many, many years. The idea that some pattern, some order, something that we recognize can emerge out of the complete randomness that takes place at a small level is truly one of the most inspiring concepts. Even in the beginning of the Christian and Jewish Bible, and also the books of many other cultures, the concept that order can spring out of chaos is inspiring. In the case of my research, the most dramatic example is water. That if you, for example, cool water and freeze it in the freezer, then the water molecules, which are completely moving around almost randomly in the liquid, suddenly become ordered in a very precise array. This is a very old example, but believe it or not, the concept of studying such systems and the ordering in such liquids as water is very much alive today. Indeed, if there were no interactions between the particles, then nothing would change. Particles would continue to move around randomly. But in fact, almost everything interacts in nature. It's very difficult to find a system where there is no interaction at all. And for this reason, it becomes possible for something to happen from these interactions. Just as interactions among people lead to patterns of behavior, so interactions among constituents of a complex system lead to patterns. The most dramatic example of that is a snowflake. A snowflake is assembled by water molecules in a very chaotic environment of the clouds. Nonetheless, snowflakes develop a pattern which every child can recognize, a pattern of typically 6 arms extending from a central core. These patterns are not like a crystal. These patterns are more like a random organization of a system where no two snowflakes are exactly identical, and yet every snowflake has a magical pattern that a child can recognize. The naive view of a system is that it's homogeneous. That means if you are a little microscopic Maxwell demon swimming around in a glass of water, everything looks the same at all times. But it's exactly the opposite of this. If you are on the size of a molecule swimming around in a glass of water, you would see regions where the water is ordered in one fashion and regions where the water is ordered in a different fashion. That's what heterogeneity means. Instead of being homogeneous, a glass of water is extremely heterogeneous. And it's these heterogeneities that we study in collaboration between Boston University and the University of Barcelona in the group led by Giancarlo Francesi. This study has led to a deeper understanding of what is special about water. The key point is that there are not two extremes only, order and disorder. This would be very simple, but in fact there is everything in between. There is nothing in nature that is completely disordered, and there is nothing in nature that is completely ordered. Instead, there is an entire spectrum ranging from almost perfect order to almost perfect disorder. And the remarkable fact is that the degree of order depends very strongly on the conditions the system is studied in. For example, liquid water, as you cool it colder and colder, it gradually becomes more ordered. The heterogeneities that I referred to a minute ago become organized one with the other and form larger and larger patches of order. Not perfect order, but almost perfect order. And the really almost perfect, really perfect order occurs when water finally freezes.